Hello students, myself Tejaswini, lecturer in EMC, State Government Polytechnic, Bangalore. We are studying the first unit, Introduction and Architecture of PLC. Now first let us have a small recap on the previous sessions. So first we have seen what is PLC. It is your programmable logic controller. We have seen the definition. What is the definition of PLC? PLC, it is a programmable device which is used to control the industrial environment. Understood? It is a specialized computer. It is nothing but a specialized computer. Then again, we have seen the why we need the PLC. We have seen some of the points why we need the PLC, like to reduce the human effort, and we can also have the complex operations. Even for the larger systems, the cost will be less, etc. Then after that, we have seen what is the history, how the PLC got developed. The first programmable concept was developed in 1968 by Dick Morley. He is the father of the PLC. Okay. Then after historical background, we have seen the applications of PLC. Today, almost everywhere in a big application or small applications, PLCs are used. Okay. And in the leading brands, we have seen like Allen Bradley, Siemens, Omron, Fanuc, etc. Okay. Then after that, we have seen how PLCs are classified. Classification of PLCs. First, it is classified into modular PLC and compact PLC. Modular PLC means it will permit the extension of the modules. You can add any components like your IO module unit, memory unit, power supply, etc. You can add. In the modular PLC, all the components are independent of each other. We have to connect them manually to form a PLC system. And the next one is your compact PLC. In the compact PLC, it is all the components are embedded in a single case. There, everything is decided by the manufacturer. Understood? So that is why the name compact PLC. It is also known as fixed PLC and integrated PLC. Okay. Then again, we classified the PLCs based on IO systems and the application ranges. Based on IO system, we are having analog IO system as well as digital IO system. For continuous signals, we are going for analog IO system, and for digital signals, we are going for digital IO systems. And based on application ranges, that is based on the IO devices, how many inputs and output terminals we can use. Okay, we have divided them into nano PLC, pico PLC, micro PLC, small PLCs, medium PLCs, large PLCs, and very large PLCs. Based on the IO devices required for your application, we are going to select the PLCs. Understood? And after that, we have studied what is the difference between relay logic control and the PLC logic control. Why today all industries have shifted from relay logic to PLC logic control. So in the relay logic control, as I already told you, it requires a more wiring for the components, and for the complex systems, reprogramming it is very difficult and it occupies a large space. In case of PLC, for even for the larger systems, you can program it from a less cost. Understood? The human effort is also less. Then after that, we have studied the advantages and disadvantages of PLC. In the advantages of PLC, if we list some advantages, first one is your flexibility, documentation, implementing and correcting errors, low cost, pilot running, visual observation, okay, then speed of operation, etc. If we list some disadvantages like fixed program applications, that is, we can't using for a single application the PLC, it is not efficient. Okay. When newer technology, environmental considerations, and fail-safe operations, etc. Then after that, we have seen what are the major components of PLC. The major components of PLCs are CPU. The CPU, we are having the microprocessor, memory unit, and power supply unit. The microprocessor here in the CPU, all arithmetic and logical operations, everything is done by the CPU, and also it will control the operations. Then your memory to store the whatever the program you're writing, we need the memory. And then power supply unit. The power supply, that is, you'll be having two different types. That is internal power supply and external power supply. Internal power supply, it is provided to the CPU. Okay, because it needs less voltage. That is plus 5 volt to the minus 5 volt. External power supply, this is to the IO modules. It may be 5 volt, 12 volt, 24 volt, 120 volt, etc. Okay. Then another component is your IO module. Then you are having programming device to enter the program into the system, and then you are having the racks and chassis to mount all the components on that. These are some of the important components of the PLC. After that, we have seen the working of the PLC. It has three steps. First, it will read and sense the input. After sensing the input, what it does, it will execute the logic. Then it will write and update to the output module. This three steps, it is called as executing these three steps, it is called as one scan cycle. It will be continuous. Okay, it is also known as scan time. Okay, so the scan time, it is measured in milliseconds. Understood? After that, we have seen the differences between data processing computers and process control computers. Data processing computers are, these are just like your normal computers. Understood? And your keyboard inputs are your keyboards, mouse, etc. And your outputs will be VDP printers, plotters, etc. But process control computers, the inputs and outputs will be same as a data processing computers, but the main inputs are for the process control computers are switches and sensors, and the outputs are solenoids, motors, etc. Understood? So your PLC is an example of process control computer. Okay. After that, we have seen the IO module, that is input output module. Input output module, it is nothing but it will act as an interface between your CPU and the real world devices. It is called as IO module. Understood? Input module and output module. There it is divided into digital IO module and analog IO module. Then also we have seen some concepts like what is bridge rectifier, what is optocoupler, and what is triad, because those things we will be using in the IO module system layout. Then we have studied input module system layout and output module system layout, how it works. See, first whatever the input signal, there all the input signals are monitored and the input signals whatever we get that are stored in the RAM. And again in the RAM it is divided into two sections. We'll be having input image file and output image file. Then what your CPU does, your CPU will fetch the input variables from the input image file, and then it will process according to your program what you have returned to the programming device, and then the output image file is filled by the CPU. Then according to that your outputs will act. Okay. So till IO modules we have seen. Understood? Now in today's session we are going to see this is the last topic of this chapter. That is memory. What is memory? Okay, why we need memory in the PLC? What is memory? Memory, it is the essential part of the system. Not only for the system, even for us. Memory is the essential part. Without that, we can't process anything. Understood? So memory is the component that stores information, programs, and data in a PLC. Okay, to store the information, so whatever you are writing the programs to store that, and the operations, if you want to store any data, you need a memory. So the process of putting new information into a memory location, that we are calling it as writing. If the process of retrieving the information from the memory location, it is called as reading. Understood? So this memory, it is made up of semiconductor switches. The position of the switch is used to represent the binary numbers 0 or 1. Okay. Now first we will see the types of memory before going to study the what the memory in the PLC, how the memory is organized in the PLC. First we see what are the different types of memory that are present. Understood? See, in the memory we are having that is ROM and RAM. Okay. In the ROM is read-only memory and RAM is random access memory. In the random access memory, we are having two types, that is read-write and read-only memory. In the read-write, again we are having two types, that is SRAM and DRAM. What is SRAM? SRAM is static RAM, DRAM is dynamic RAM. Static RAM. Static RAM, it stores the data in static form. The data, it remains in the system memory as long as the computer system is on. The data will be there as long as the system is on. Okay. SRAM is faster than DRAM. And in case of SRAMs, we are using only transistors. Transistors are using. So that is why SRAM is little bit costlier than your DRAM. But it is faster than DRAM. In the SRAM, refreshing is not required in the SRAM. Understood? Next one is the DRAM, that is dynamic RAM. In the dynamic RAM, we are using both the transistors as well as the capacitors. Since we are using the capacitors, wherever we use the capacitors, the leakage problem will be there. So to avoid that, the refreshing the memory circuit is always required. So always DRAMs are slower than the SRAMs, and DRAMs are cheaper than SRAMs. Okay. And in the read only, we are having ROM, PROM, EPROM, and in the EPROM, we are having UV EPROM and EEPROM. Now we will see one by one. First one is RAM, that is random access memory. Already you know the random access memory. Random access, if the contents of the RAM can be altered. So a computer can both read from and write to memory address in the RAM. This is the read-write memory. It is a temporary memory. RAM is described as volatile, meaning if the power is switched off or the battery removed, the contents will be lost. That is why it is called as temporary memory. Next one is PROM, that is read-only memory. Read-only memory, it is the permanent memory. Even if the power goes off, the contents will not be erased. And here we cannot alter any contents in the ROM. So that is why it is called non-volatile. Understood? Next one is PROM, that is programmable read-only memory. PROM is also just like your ROM, but in case of PROM, here we can program only once. So whenever we get from the manufacturer, it may be semi-programmed or it may be it will not be programmed. Then the user, when he gets, he can program according to him however he requires. But once it is programmed, you cannot reprogram the ROM. If you want to reprogram it, you have to throw away and you have to get a new ROM. Understood? So for more specialized users may like to store his special function or program to ROM. Here, information will only install once. That means we cannot reprogram this again. Programming is done using special writing circuits. Time taken to write information is long, while read time is small. Not flexible, because we cannot reprogram it. Understood? Understood the PROM? That is, PROM is the programmable read-only memory. Next one is your EPROM. What is EPROM? That is erasable programmable ROM. So erasable, in the name itself, that we can erase the program and we can reprogram it. In the EPROM, what happens here is whatever we write the data, we can erase the data and we can rewrite. How we are erasing the data? There will be a window on this EPROM. There a UV light will be passed onto this memory. Then what happens? The data will be erased. Then again we can rewrite or we can reprogram this memory. So by using UV light we are erasing the memory. It is also called as UV EPROM. Understood? So once it is erased, all the bits will be reset to 0. Okay. But the disadvantages of the advantage is that is we can reuse this EEPROM. But what are the disadvantages of EEPROM? First one is downtime. Downtime means the time required to erase the memory. That is, you have to subject to the UV light. Understood? Then again you have to reprogram. Reprogramming time, erasing time. This is the downtime is more for this EEPROM. And one more disadvantage is you can't erase the program a small part or a bit by bit. You want to erase the entire program, and again entire program you have to reprogram it. These are the two advantages of EEPROM. Okay. And next one is a double EEPROM. What is double EEPROM? Double EEPROM is electrically erasable programmable ROM. In the name itself there, we are using the electrical signal or pulses to erase the memory instead of UV light. Okay. So electrical pulses are used instead of UV light to erase the ROM. Erasing ROM with electrical voltage is convenient compared to UV rays to erase it. Why? Because in the EEPROM, when you erase, the entire program will be erased. But in case of double EEPROM, so whichever part we want, we can erase only that part. Understood? So the downtime will be very less and the reprogram time is also very less. So that is why today double EEPROM is the leading technology. Understood? And next one is your flash RAM. Okay, this flash RAM, it is the combination of double EEPROM and RAM. That is your NOV RAM. It is the random access memory. It uses one transistor switch per memory cell. The capacity is ranging from 32 KB to 1 GB. But it is a non-volatile. Do not require power to preserve the data. See here what happens in this. It is a combination of double EEPROM and RAM. When the power is about to go off, immediately the data that is stored in the RAM, it is transferred to the double EEPROM. And when the power comes, again it is retrieved from the double EEPROM to the RAM. Read time of flash memories is tens of nanoseconds, but while write times it is microseconds. Read times is faster than write times. It is compact and came in various shapes. Examples of flash memory are your pen drives, microcards, etc. These are some of the examples of your flash memory. What are the advantages of this flash memory? It is random access, it is non-volatile, slow in write, fast in read memories. We can overwrite it. It is very compact. Price/byte is rapidly reducing. Okay. These are the different types of memories. And memory size. What is memory size? You have heard that this is 1 GB memory, it's 2 GB memory, 512 KB RAM. Okay. How you are going to define it? What is that? That is your memory size. You are telling the memory size of the RAM and ROM. Memory chips, whether volatile or non-volatile, they are classified according to the bit or cell size. The bits are 0 or 1 that occupy a given cell. Cells are arranged in slots, usually 8 or 16 bits wide. When the bits are combined, they are called words. See, if you see this diagram here we are having 8 bits, that is from 0 to 7. And this side, on the left side, it is addresses of the memory location. Or combining all these 8 bits, we are calling it as a byte. An 8-bit word, it is called a byte. Understood? So for 1 byte, we will be having the 1024 bits. So that is why if you see the addresses here, we have an address from 00000 to 1023. That is 1024 bits. That is, you are having the locations. Okay. Next, 2 bytes. 2 bytes means how many bits we will be having? It is a 16-bit word. Okay, if you see the next diagram, from 0 to 15 we have written. It is the 2 bytes memory. This is the 1 byte memory and this is the 2 bytes memory. 0 to 16 bits, and the addresses are from 00 to 1023. Understood? So this is about the memory. If we summarize today's session, we have seen the types of memory in the ROM and RAM. In the RAM, we are having read write as well as read only. In the read write, we are having static RAM as well as dynamic RAM. In the read only, we are having EEPROM, double EEPROM, okay, and this one your flash memory, etc. Okay. Now let us solve some MCQs based on this session. The first question. The type of memory which is fast and temporarily stores the data which are immediately required for use is called as dash. See, first thing, it is fast and it is temporary. Which is a temporary memory? HDD, ROM, RAM and SSD. Your RAM is the temporary memory, that is a random access memory. ROM is the permanent memory. Next, second question. The UV light is used in which type of memory? UV light, that is ultraviolet light. A. ROM, B. RAM, C. EEPROM, D. PROM. See, we are using the UV light for erasing the data. In which memory we are using? It is EEPROM. Understood? It is erasable, programmable, read-only memory. EEPROM is the answer. Next question. Non-volatile random access memory. NOVRAM, it is a combination of, it is nothing but your flash memory. It is a combination of double EEPROM and RAM. Understood? Double EEPROM and RAM. Fourth question. The operating system or executive memory for the PLC is always in dash. The operating system, the OS, okay, for the PLC is always, it is ROM, that is read-only memory. We cannot alter anything there. Next, fifth one. When talking about computer or PLC memory, 1K refers to dash bits, bytes or words. How many bits? We have seen the memory size, 1K. 1K is refers to the how many bits? That is 1024 bits. Understood? 1024 bits is the answer. Okay. I hope today you understood the session about the different types of memory. Thank you for listening.